So that last example should have motivated us to find a better way to compute areas under curves, and that's what we're going to do now. So we do need an easier way to find these values of these definite integrals, and we're going to do two examples to lead us to a way to do this. So our first example is this function that I've drawn here, and just one comment, which is in a recent semester, one student wrote on the discussion board online that she couldn't understand this example because she couldn't find a formula for this function. Remember that not all functions have formulas. There is one for this. I mean, I could make a piecewise formula. It's just 3 different lines. But if I just draw some graph, that's a function, but there's probably not a formula for it. There's some formula. There's the temperature today is a function of time, or the price of Google stock over the next year is a function of time, but probably nobody knows what the formulas for those are, even if there are formulas for them. So whether we can write a formula or not, this is an actual function. So I've got this function, I'm calling it f of t, and I'm going to make this new function that we haven't seen before. It's called the area function, or particularly the signed area function, because again, we can count area as negative when we fall below the x-axis. So a of x will be the integral from 0 to x of f of t dt. So it's the area under this curve from 0 to whatever x I plug in. So I plug in x equals 2.3. It means I start here at 0, go over to 2.3, and however much area we've gotten, how much signed area we've gotten, that's the value of a of 2.3. So let's try to see if we can understand this by filling in a few values on the table. So I'm actually just going to fill in a couple, and then we have an applet for you to play around with this function to try to answer all of these questions, and then we'll come back and we'll discuss the answers together. So if x is 0, what's a of 0? A of 0 says start at 0 and just go to 0. How much area are you going to get? Well, if I start here at 0 and I don't go anywhere, we're not going to get any area. So a of 0 will be 0. What about a of 1? That means it's the integral from 0 to 1 under this curve. So that's the area of this rectangle. So a of 1 is the area of this, did I just call it a rectangle? Of this triangle. Of this triangle. And the triangle has a height of 4 and a base of 1. So the area of the triangle is 1/2 base times height. So a of 1 will be 2. That's how this function works. It's the integral from 0 to 1. Says how much area do I get under this graph of f from 0 to 1. I'm intentionally using a different letter t here than x. If you want to use the same letter, it doesn't really make any difference. I think it's a little easier to understand if we use a different letter here. So x is whatever point I've gone to along this axis. So try to fill out the different values here, either by using this picture or by using the applet. And then also try to answer these questions. Where is a increasing and decreasing? Where is a concave up and concave down? And then we want to sketch what a of x looks like. So give those a try, either with or without the applet, and then we'll come back and fill in the answers.